Hello everyone, I'm so excited to join the class today to share my work on human-AI collaborative methods for instructional design. In my research, I develop computational methods and tools to support education. I see instructional design as an area where human-AI collaborative methods could be impactful, as it requires expertise and planning from instructors, and at the same time, AI and data could empower instructors in their decision-making processes. In this talk, I'll be focusing on one project where we harness students' written solutions to support instructors in creating scalable learning opportunities. Large numbers of people are seeking higher education and professional development. For example, people learn in university classrooms, which may look more like this right now. In addition to physical programs, universities and higher ed companies are opening online programs to accommodate more students. And at the same time, companies are also growing professional training programs to better support their employees' career choices. For all of these educational service providers, one challenge to meet the demand is to scale these educational opportunities while maintaining or improving their quality. As we have mentioned earlier, there is a growing need to create meaningful learning opportunities. Traditionally, experts or instructors take the most responsibility in providing learning opportunities, for example, by giving lectures, offering feedback, and preparing tutorials, etc. As we observe and interview experts' current practice, they still face big challenges and receive little support in creating learning materials. For example, for a college instructor, when writing an assignment question, a typical workflow is to open a Word document and start from scratch, or copy and paste materials from the past and make edits. The challenge becomes even more salient when experts need to do this at scale. On the other hand, AI-based technologies have made progress over the years on scalable instruction. For example, there are existing auto-grading systems, but they cannot be applied on all content domains and usually don't provide natural language feedback to students. Intelligent tutoring systems can adaptively select problems for students and offer feedback, but they also require huge authoring efforts upfront. There are also many existing automatic question generation techniques, but many of them only produce fact questions or have rigid templates that only allow for the change of specific parameters, thus not flexible. At the same time, peers are producing content all the time. A peer can be a student who took the class last year, or it can be someone on the web who just uploaded a video to YouTube. I begin to explore how we can leverage machines to mine the underlying expertise from the large group of peers and transform them into useful materials. I also explore how we can involve experts in the process to guarantee the content created is of high quality. And in the rest of the talk, I will introduce how to leverage the complementary strengths from peers, experts, and machine to support content creation at scale. From the paper on active learning that you have read before this class, the most important takeaway here would be that active learning is better than passive learning, and we need to strive to create active learning opportunities for students. Then the question becomes how to create active learning opportunities easily and how to create them at scale. We know that it would take a lot of efforts from experts to be able to create quality learning opportunities. But what are ways that we can minimize the involvement of experts, but at the same time to also make sure the learning opportunity produced are of high quality? We have mentioned a little bit that maximizing system scalability and quality are sometimes at odds. For example, in one-on-one tutoring, students may receive individualized feedback. However, this doesn't scale. Another example is in MOOC lecture videos. On the one hand, it makes lectures easily scalable. On the other hand, it doesn't provide interactive forms of learning by doing, which was found to produce higher quality learning, which should be a main takeaway from the active learning paper that you have read before this class session. Let's look at another example. Open-ended assignments or projects are frequently given in college classrooms. They often require lots of efforts on grading and offering feedback from instructors, thus hard to scale. On the other hand, multiple choice questions are naturally scalable since they can be automatically graded and provide real-time feedback to students. And then the question becomes how to achieve quality and scale at the same time. And in this context, how to create multiple choice questions that exercise higher order thinking and achieve the same level of learning as open-ended tasks. In this talk, I will introduce a system upgrade that uses human-AI collaborative methods to create high-quality multiple-choice questions by leveraging existing students' written solutions. Before I started, I talked to 5 instructors to understand their current practices and challenges, and we got many comments regarding the frustration around grading open-ended assignments. For example, one instructor teaching a survey design course said that students are asked to design a survey when they didn't actually know how to do it, and many assignments turned in were in very bad shape. And another teaching assistant of a research methods course said that students are having very similar mistakes and just copying and pasting the same feedback to a lot of them. So one design consideration of upgrade is that since we are anticipating common student errors, giving them practice opportunities beforehand to avoid these errors can be powerful. And upgrade naturally identify these common errors by drawing on incorrect solutions from student sources. I will explain how the technique works in the context of learning heuristic evaluation, which is a usability inspection method in user interface design. I will now take a minute to explain what is heuristic evaluation. In Gmail, immediately after I sent an email, I got this interface that says message sent, with 2 buttons, undo and view message. One thing I like about this interface is that I can undo it. This is an example interface that supports the rule of user control and freedom, because users have the freedom to undo this action if they accidentally hit the send button. Now let's look at another interface. On eBay, on the purchase page, I see buttons commit to buy or continue with PayPal. What might be an issue with this design? The only option for users is to buy. There are no access for users if they decide to shop more. So this is an example that violates the rule of user control and freedom. Okay, now I hope you get a basic understanding of what heuristic evaluation is. And when we teach heuristic evaluation in college methods courses, an open-ended assignment we give students may look like this. Go find 5 web design features that violate certain web design heuristics and explain why. Here is an example student solution in response to this assignment question. You can see a screenshot from a PDF file a student submitted. Let's zoom in a little bit. First, here's a web design feature that they found is the checkout page on eBay. And then they described this design violates the rule of user control and freedom. And then they explained this is because the website didn't offer an emergency exit. Using this as input, Upgrade first segments this open-ended solution submitted by a previous student into these 3 sections, including a web design feature, a rule violation, and an explanation of this rule violation. And then the system will restructure these components to produce multiple choice questions. A target multiple choice question produced would be like this. The web design feature is used as the question stem, and the question asks, which of the following heuristics does this violate? The original student's answer is used as the correct answer, and the distractors are selected from the pool of answers offered to similar problems. Additionally, the original student's explanation is used as feedback for this multiple choice question. You may see that in this multiple choice question produced by the system, all of the text here are sourced from existing student submissions. The goal of the system is just to segment and reorganize the text. And now I want to give an overview of the workflow of Upgrade. Upgrade is leveraging the capabilities of both humans and the machine. Past students function as a crowd that offers data source, and the machine segments, selects, and reorganizes examples. And in the end, the expert validates the questions as a quick quality control. This workflow enables Upgrade to quickly produce good quality multiple choice questions at scale. Now I will talk about each step in details. Step 1 almost happens naturally. Past students' written solutions are logged. They can be logged in PDF formats or through online forms. And this is the one example that we just saw. In step 2, the system segments the written solutions into sections based on the assignment template and the DOM tree structure. So in this one example, this student solution is segmented into these 3 sections, including a web design feature, a rule violation, and a reason for rule violation. In step 3, we require the instructor to specify a question creation schema in which the instructor will specify which components in the source will be used in the target question. Again, in this example, the source answer, which is the web design feature, is used as a target question stem. The source answer, which is the rule violation, is used as a target correct answer. And the instructor also needs to specify the system needs to select incorrect answers. And then, lastly, the source answer, which is the explanation for the rule violation, is used as the feedback for the target question. In step 4, the system reorganizes the source data based on the schema the instructor created in the last step to create multiple choice questions. One critical step here is to select distractors. And we apply 2 text processing techniques to select distractors. First of all, we select plausible answers as distractors. We computed the word vector similarity between the correct answer and every other answer in the pool and select those that are similar to the correct answer as distractors. And second, in our iterative design process with instructors, they prefer to use generic answers than specific answers as distractors to prevent students from getting the correct answer by simply matching keywords or surface features. And we applied a dictionary to compute the abstractness score of each of the answers, and then we prioritized the answers that are more abstract as distractors. In the last step, we ask instructors to select questions from the large question pool. For this one question schema with past student solutions in one offering of the course, which includes about 80 student submissions, the system is able to create nearly 500 multiple choice questions. And now the instructor's goal is just to say yes, no, or maybe to these questions, and perhaps make edits when necessary until she finds enough to deliver to the class. We now see that Upgrade can produce multiple choice questions at scale, but are the Upgrade-produced practice questions helpful for learning? To find out the answer, I conducted 2 experiments in 2 college-level courses. In Study 1, it was done with 28 students. In the experiment, we divided the whole class into 2 groups. In the first week, they are learning about survey design. And Group A, they did the traditional open-ended assignment, which is to design a survey from scratch. And Group B, they did the Upgrade produced assignment, which is composed of 50 multiple choice questions. In the second week, the 2 groups switched. So they are learning about heuristic evaluation, and in this case, Group A, they will do the Upgrade assignment, and Group B, they will do the open-ended assignment. Following each week, we administered a quiz that's composed of both multiple choice and open-ended questions as the learn outcome measures. Here are more specifics about the multiple choice assignment produced by Upgrade. The questions are rendered through a web-based platform, and there are multiple sections. Each section corresponds to one question schema the instructor specified. Within each section, there is a list of questions to give students repeated practice on these topics. And you may see here, after the student pick an answer, the questions offer immediate feedback. And as we have introduced earlier in the workflow of Upgrade, all of the text here were sourced from existing student submissions. We require input from the instructors at 2 steps. One step is to create a question schema, and the second step is to select the questions in the end. This is to make sure that the quality of the questions are reasonable, and also we want to minimize the input from the experts to save their time. As a result, we found that students learned the same through both conditions. The light bar here is Upgrade, and the dark bar here is the traditional condition where the students did business as usual open-ended assignments. You might see that the trend is slightly favoring the Upgrade condition, but the difference isn't statistically significant. On the other hand, we do see a significant time reduction between the 2 conditions. the average time students spent on their open-ended assignment was 6.5 hours, and when doing upgrade is reduced to 4.5 hours. This suggests that students learned as much with upgrade as traditional open-ended assignments in 30% less time. We also got feedback from the instructor of the course afterwards. She liked the approach since the student grades are computed automatically, saving substantial efforts of grading and offering feedback. And she also suggested using upgrade as a precursor to open-ended tasks. She expressed concerns around the low quality of open-ended work students turned in, saying many assignments were in very bad shape, and I had to tell the students to go back and redo it, and suggested that future practice could get students practice with upgrade first and then go off to generate new content. Following the first experiment, we also did a second experiment taking the instructor's advice to use upgrade assignment as a precursor to students' open-ended tasks. And this was done in another research methods course with 89 students. So again, we divided the whole class into two groups. And in the first week, they were learning about think aloud protocols and usability findings. The traditional assignment is a week-long group project. In the upgrade condition, we give students an exercise composed of 20 multiple-choice questions produced by upgrade before the students worked on their projects. And in the second week, the two groups switched when they are learning about storyboard and speed dating techniques. We use the quality of students' open-ended projects as a learning outcome measure. As a result, we found that students' performance on storyboard projects increased after using upgrade. As you can see in the bar chart, the lighter bar is the upgrade condition. Though we do not see a statistical difference on the performance of the usability findings project. We got some positive feedback from the instructor on the quality of questions produced by upgrade this round. So this one instructor said, when I write multiple choice questions myself, the distractors I write tend to be obvious and easy. In this approach, I see more plausible distractors, even I have to think about which one is correct, which is good. And the instructor also said the storyboard questions are really good. I'd like to use them as training materials for the program's capstone projects. One major takeaway from this iterative design process working with instructors to try to use upgrade in their classroom is that the close collaboration between humans and the machine is the key to success in this case. Traditionally, with instructors alone, it is hard for them to write lots of elaborated good examples and wrong answers when they are creating assignment prompts or creating questions, or even creating examples to use in lectures. And we also see that with machine alone, existing techniques, they mainly produce fact questions or that they require very rigid templates that are not flexible to be used across domains, and the quality also isn't satisfactory for instructors. In the case of upgrade, past peers offer a powerful data source with structured examples that show common errors. With this better data input, machine can auto-select, filter, and reorganize examples. In this process, instructor is also communicating their needs, such as I want similar examples, I want technical answers, I want more abstract, generic answers as distractors to guide the machine in selecting these examples. In the end, the instructors will also check information accuracy and comprehensiveness to make sure the quality of the questions are good. And this altogether supports the creation of quality learning opportunities for learners. In this process, we also observed scenarios that the technique doesn't work very well, which points to future directions. In fact, we found that the success of upgrade is associated with the quality of data input. For example, when we have structured examples from students and feedback on these examples, upgrade would produce higher quality content. We suggest future pathways for experts to actively collect better examples and design activities so that students are self-annotating their own examples. And this can serve as better data input for machine for further processing. And we also see further processing opportunities by the machine. For example, in a module that the technique didn't work very well, it's because the students' answers have many irrelevant information. Future work could explore stripping off irrelevant information using natural language processing techniques. Upgrade has been mainly applied to create homework assignment questions. During our iterative design process with instructors, we also see desires and opportunities for upgrade to create a large variety of activities, including in-class activity, collaborative activity, peer instruction problems, assignment rubrics, etc. As I continue this work on developing AI-augmented learning experience authoring tools, I hope to explore a diverse range of data sources. In Upgrade, we used students' written solutions. It's possible to also leverage, for example, students' conversations and Q&A in forums, teacher feedback to students. These data sources are powerful because they contain information on students' common errors and struggles, and they also provide authentic, relatable examples to a diverse student population. And then I'm interested in further explore human-AI collaborative approaches to create higher quality learning experiences, and not limited to multiple choice problems. These can be collaborative problems, branching scenarios, role plays, etc. And if these topics sound interesting to you, and if you are interested in working on human-AI collaborative methods, techniques to support instruction design and assessment design, or education technologies in general, please don't hesitate to reach out to me, and I'm actively recruiting students to join my lab to work on research projects. And thank you, everyone. See you later in class.